gentlemen, thank you for joining us for today's webinar, Delivering the Clean Energy Transition, Valuing T&D Investments to Support Grid Modernization, sponsored by Copperleaf. My name is Hugh Jones with T&D World. Before we begin, a few words about the webinar technology. This platform allows our audience to be more involved with the presentation and, more importantly, allows you to watch this event the way you want to watch it. To begin, feel free to customize your webcast console. You can move windows around by dragging on the title bar or resize your windows by clicking on the lower right corner of any window. You'll notice a toolbar at the bottom of your console. These buttons allow you to open and close widgets on your screen. If at any time you experience technical difficulties with the audio or advancing of the slides, simply press your F5 key on your keyboard to refresh your webinar console. We encourage you to ask questions at any time using the Q&A widget on the left side of your screen. We'll address as many audience questions as possible at the end of the presentation. And now I'd like to hand things over to Rachel from Copperleaf to get things started.
Great. Thank you, Hugh. Hello, everyone. Thank you so much for joining this discussion today around valuing grid modernization plans. I'm really excited to be here and to be joined by our two panelists. So we're going to introduce ourselves, the webinar audience, and then I'll go over the plan for our time together. So why don't we start with you, Jay? Could you please introduce yourself?
Yes, had a little hard time with my camera all of a sudden. Sorry about that, but this is Jay Oliver. I'm with Duke Energy here in Charlotte, North Carolina, and I am General Manager of Grid Strategy and Asset Management Governance for Duke Energy. And I spend a lot of my time valuing transmission and distribution investments. So this will be a good day.
Great. Thank you, Jay. Hope you can get the camera sorted out. In the meantime, Joe, could you please introduce yourself?
Thanks, Rachel. Good morning, good afternoon, everybody. This is Joe Zhao from Black & Veatch Management Consulting. I lead a number of business lines within Black & Veatch Management Consulting. We focus on asset management, risk management, operational technology, distributed infrastructure, asset management, AMI, smart grid, and customer information systems. And like Jay, I've been working in the utility industry for many, many years, and it was really a great opportunity to spend some time with you all and to discuss how we value grid transformation investment projects.
Awesome. Thank you. Thank you so much. Great. Well, I can go next. So my name is Rachel Griot, and I am a lead for the Solutions Consulting team for the Americas region at Copperleaf. So my background is around working with organizations such as Duke Energy and with our partners such as Black & Veatch to really tackle some of these challenges around planning and coming up with the best investment plans that are aligned with strategy and that make sense to regulators, to shareholders, et cetera. So at Copperleaf, we've been working for many years with transmission and distribution operators, helping them improve the way that they do their short and long range planning, helping them ensure that you're really spending each dollar you have in your business in the best or the most valuable place. So we've seen the energy transition really transforming the way organizations plan. So we wanted to come together today to discuss some of these planning challenges around grid modernization and the best practices for addressing them. So it's our hope that everyone watching the webinar can take away something valuable from today that they can apply to their own planning organization. So how we were thinking this would go today would be that we'd have Jay and Joe actually jointly present a presentation they have around asset investment planning trends and challenges. So we'll do that for about 40 minutes. And then after that, we'll open up the conversation for a Q&A. So we really want to try and make this as interactive as can be, given that it's a webinar. So for everyone watching, please don't be shy, write questions, comments, feedback in the chat, and hopefully we can get your thoughts and perspective into this presentation as well. So yeah, without further ado, Jay, Joe, I'll give you the floor and we can start the presentation.
Great, thanks, Rachel. Like Rachel said, Jay and I are going to try to tag team on this thing. So it'll be interesting for all of us. What I'd like to really start with this presentation is really kind of set the stage and context for why we're having this conversation today. I think one of the key trends that we all see in the industry is really the acceleration of grid transformation. And when we look at decarbonization, electrification and hydrogen movement in really the grid space. With the policy that are going to drive these transformations, we see a much faster acceleration. And especially when, many years ago, even like about 5-10 years ago, there was a lot of discussion on we got solar, we got wind, and somehow, the utilities are not going to survive. But really the opposite has really come to become true in the sense that utilities are at really the center of delivering energy, reliability, and really, the safety for the society. And we're all being really excited working in this industry. What we see is really sort of a dichotomy of electrification of the society driving the demand. But at the same time, we also see potentially a green hydrogen evolution or revolution to really understand where the eventual energy landscape will look like. And as a result of that, and we believe that, the entire value chain of generation, transmission, distribution are going to be very, very different, even in 10 or 20 years from now. And that's why we're here and talk about how we are going to value these investments, because in the end, the customers are going to essentially pay for these investments to be able to deliver the energy to them. So with that, I'm going to turn it over to Jay.
Yeah, thanks, Joe.
Oh, I think we might have lost Jay there, Jay's audio. So let's, maybe we can continue on to the next piece, and then we can loop Jay back in to finish his thoughts on this slide. What do you think, Joe?
Yeah, can you still hear me, Rachel?
I can hear you.
Okay. Why don't I continue with this, and then we can go to the next slide, and then see when Jay comes back. And we're living in the days of remote working, and I think sometimes, obviously, connectivity and bandwidth are going to be an issue, right? So hopefully we're prepared for things like that, even in the live webinar. So really the point that Jay was going to talk about is think about where we are with really extreme weather events and really security threats that our utilities are faced every day. And to be able to not only design a physical grid, right, that are supported by these extreme weather events, but also design the grid from a digital sense to fend off some of these security threats, are going to be really the new challenges that we all have to be faced with. And with that, the entirety of the investment portfolios are very, very important, as well as some of the asset improvements that traditional utilities are have been looking at for some time. So Jay, are you back on?
Yes, I'm back on.
I see your video.
Welcome back.
Yep.
All right.
Thank you. Yeah, I had some internet issues.
Welcome back.
And I'll pick up right where I left off, if that's okay.
Sure.
We talked about Duke Energy's carbon decarbonization goals. The states we serve, many of them also have goals. The federal government has goals. And many of our customers have sustainability goals that are very important to them. In fact, they may not be able to operate in our areas if they can't meet those sustainability goals. Further, our residential customers are very interested in us providing the cleanest energy possible. All of that makes decarbonization of extreme interest to us, and being able to value that effectively is of course very, very important. Also to mention extreme weather. The weather is changing. We serve Florida, North Carolina, and South Carolina among the 6 states that we serve electrically. And each one of those suffers hurricanes. And we've noticed an increase in the damage caused by those hurricanes and a more frequent occurrence of those. Something else we have to be able to value in our grid improvement plans. Another one I'll mention is threats to the grid from a physical and a cyber nature. We've seen those increase over the years, and the amount of traffic that we get trying to get into our systems, I think is pretty alarming. I'm not going to say what the numbers are, but they're up there. We successfully can block those, but also the physical threats are out there. So those are another very important things to take into consideration in your grid modernization plans, and all those opportunities do work together. And I'll mention one other thing just to get it out there on the table, and it's the electric vehicle transition, and specifically transportation fleets, delivery vehicles like the Amazon trucks or the UPS trucks or FedEx trucks. As those begin to transition from traditional combustion engines to electric vehicles, it changes what we have to serve from an electric perspective dramatically. Think about maybe something that makes sense to everybody. Think about a traditional grocery store, what you might see in a traditional grocery store, that amount of electric usage. Now think about a shopping mall. The difference between those two is the difference between a traditional large depot for fleets that do delivery and a depot that is using electric vehicles, a dramatic increase in load that we have to be ready for also. And we can go to the next slide.
Great. So I'll start off with this one. Really what we're looking at is, think about these different challenges and accelerating drivers of the industry. Where we see the grid of the future will look very, very different than what we see today. If you look at the events that just happened a couple of weeks ago in Texas, right? Texas winter storms, and we had really huge challenges around the reliability and resiliency. And one of the things that I believe and we believe is that the value of reliability and resiliency are really very much undervalued, if you will. And that's really an issue, because when we do not have ability to drive the probabilistic occurrence of these events and then be able to then put a value on reducing or avoiding those catastrophes, then we don't have enough investment in the redundancies, in the resiliency of those technologies across generation, across transmission, and across distribution. As in addition to that, we do not have enough investment in the digital technologies to do all that, and that's really being a challenge. So part of this, this journey that we're embarking on with Copperleaf and with Duke Energy is really looking at how do we normalize the different characteristics of the grid of the future and really understand, the breadth of grid investment that we have to put in place, and then be able to then articulate the value beyond the traditional reliability improvements, going to address the resiliency, the sustainability, and the flexibility of the design of the grid. And that's really the challenge in front of us. Jay?
Yeah, thanks, Joe. And I'll add just a couple of things here. So we're a regulated utility in the areas that we serve, and to change the nature of the grid, to get the investments approved by our regulators, we have to be able to show that value. And Joe just talked about, what some of those investments are. You got to show that value in a quantitative fashion, and you have to be able to show that you have compared different alternatives. These are things that always get asked when we bring a plan to our regulators for improving the grid. What alternatives did you consider? Why is this the best alternative? What are the benefits associated with these alternatives? Why should our customers pay for it? All of that is very important. Comprehensive capital planning, and a comprehensive capital planning tool that allows us to go 5 years out and value different types of investments is very, very valuable for us in making that case. And with that, we can go to the next slide. And the next slide, the title is Impact of Integrated System Planning. And I can see the slide. That's great. That's the first time I've been able to see it. I'm having some internet issues. So this is very, very important to Duke Energy. We call this ISOP at our company. And that stands for Integrated Systems and Operations Planning. That includes asset planning, and it includes investment planning. and also capacity planning. And all these have to be related in order for this system to work in conjunction as one. Now, if you think about traditionally, generation did a plan, transmission did a plan, and distribution did a plan, and rarely did those plans touch. Those days need to be over. All three of those disciplines need to be coordinated in how they're working together and making their plans. And we've started on that at Duke Energy. One of the ways we're doing it, and I'll just highlight something on the distribution side, is with a tool called Advanced Distribution Planning. We call it ADP. And instead of just traditional peak forecasting, because a lot of distribution planning is based on peak loads, we take a 10-year, 8760-hour view versus just that traditional peak. And when you combine all of the circuits and put that in a software package with all of those data points, it's very interesting some of the gaps that show up and some of the opportunities that show up. Now, we fully expect that we're going to be able to value and use more non-wire solutions going forward because of that tool. We're still in the early stages of it, but it's also something that we're very excited about. Now, asset planning and capacity planning, these are related, and I want to make sure we think about that going forward. Many of the investments, traditional investments that we make in the grid, upgrading our transmission system, automating substations, upgrading the distribution system by adding capacity so we can backfeed circuits that help with resiliency during outages, automating the distribution grid that allows us to understand where load is flowing, allows us to manage VAR flow more effectively and manage voltage more effectively. All of those have immediate value for our customers, and those are asset type programs, but they also have a capacity value because it does allow us to embrace cleaner energy, customer owned, for example, cleaner energy into our system in a much more effective way. So you got to value both the traditional and the non-traditional. And with that, I'll turn it over to Joe.
Thanks, Jay. Really, I think the key point here is really the integrated nature across the resource planning, the system planning, and asset investment planning. And clearly, Duke is leading the way, but we've seen that in a number of other utilities that we've worked with. And what's interesting is that traditionally, you don't see utilities file their integrated resource planning with their rate cases or with their investment planning together. But now we see actually them trying to timing it. Because in the end, to really achieve the resource planning goals, especially when it comes to carbon reduction goals, you really have to take into consideration of, for example, demand response programs, your non-wires alternative investments, and can your distribution grid actually deliver the automation goals, the voltage reduction goals, or the other goals that we put in place to support your resource plans. And all that really speaks to essentially a digital transformation within the system plan and investment plan world. And it's no longer, sufficient for people to looking at spreadsheets and spreadsheet models to trying to do this. And that's really what we've seen in the industry. Next, please. So let me continue on really then and talk more about specific to the investment planning challenges. We talked about the resource planning and system planning. What we've also seen then is when it comes to asset investment planning, it's going to have a number of key challenges. And the key part of that is understanding that your value requirements are going to vary by jurisdictions. So, like Duke Energy, and they work in multiple states, and they have to look at individual state requirements and really trying to tailor those evaluations to each state requirements from timing perspective, from the level of the detail. Now, how's that going to then impact your really benefit cost analysis from an internal budgeting perspective, as well as aligning that to your external requirements from that perspective is going to be a key challenge. So what we see is that, without a really comprehensive process and without a really a sophisticated tools to help you manage, to align your internal budgeting across generation, transmission, distribution, as well as focus on not only articulate the value of your reliability improvements, which, is still going to be by far the most significant value from a quantitative perspective, you're going to start to essentially strengthen your business case by adding a number of other benefit categories, which we'll talk about in the next couple of slides. But the key is, how do you normalize those and be able to articulate really a comprehensive business case and to really, make your case to your regulators and to your customers. And that's the challenge that we believe the industry is faced with. And Jay will get into more details and some of the examples what Duke is working on.
Yeah, thanks, Joe. So I'm going to go down to point number 6, where it says Grid Mod strategy and roadmap. And it says, what are your no regrets investments? This is a very important question, because no regrets investments are important to our regulators and important to our customers, because we make some assumptions about growth in electric vehicle fleets. We make some assumptions about continued development of distributed energy resources, and that maybe batteries are going to become more cost effective over time. And we're planning based on a lot of those assumptions. And I think they're very valid assumptions. However, no regrets means even if some of those assumptions don't come true, if we stayed flat with our distributed energy resource growth, or electric vehicle growth seemed to stall, or batteries never got less expensive or more efficient than they are today, we would still make the vast majority of these investments because there are no regrets. So the way we valued some of these investments, and an example of that is a program we call Self-Optimizing Grid. Self-Optimizing Grid is essentially a way where the grid automatically recovers from an outage. So on our main feeder circuits, our main distribution circuits, when we experience an outage, we have built-in automation to where we'll switch around that problem without human intervention. So you need to have sensors, you need to have system intelligence, you need to have SCADA control of the devices in the field, and you have to have the capacity and the connectivity built into your distribution system, all of which are very, very important for growth of distributed energy resources. But we can make the case for that type of investment with the reliability and resiliency benefits alone that they bring. Now, again, many of our territories, we operate in areas that suffer from major events, extreme wind events and storms. And so we can estimate the amount of time that our customers will remain in service because of investments like those. That's a no regrets investment. And those are very important. And as you're building these cases, make sure that you think about that and are able to talk about what those are. And the next thing I'll talk about is item number 5, and it's benefit cost analysis and external facing benefit cost analysis. What you have to show is that the customers that you serve are better off because you're making this investment. Very, very important that you do that. And one of the ways that we do that is with VOLL, or value of lost load. Value of lost load essentially puts a value on customers' usage of electricity. Now, I've represented Duke Energy in many rate cases and represented Duke Energy in specifically grid modernization proceedings as well. And this comes up. And there's a lot of questions about how much do customers value electricity, residential customers versus commercial versus industrial. And there is a standard for that is used. And that is built into our capital planning assumptions, and it allows us to actually make these benefit cost analyses. So value of lost load is a very important part of what we do, very important part of what many utilities use to value these programs, but it's certainly not the only thing. It is a way, however, to approach the no regret types of investments. And so we use it that way, certainly. And I think we can go to the next slide.
Great. So let's take a deeper look at what kind of grid mod investment projects and programs is Duke looking at, or is really the industry looking at in general. And we kind of break it down into sort of the 4 quadrants. And there's certainly the physical aspect of the grid transformation, But there's also equally important, if not more important, the digital sort of aspects to transformation, both from a short-term and long-term perspective. And when you look at these investments, a lot of that really has a long-term implication. So Jay talked a lot about, no regret investments, and that's really how we want to look at it, is that have your short-term investments really supporting your long-term goals, both from a physical transformation perspective, right, but as well as from a digital transformation perspective. And I'm not going to go through and read every one of these bullets. Really, the key message here is that as we go through these transformations, one of the things that we have worked with utilities and utilities have been looking at is think about this very much holistically, right? And how do you want to transform transmission, substations, and distribution from a physical sense? If you're going to break down your grid, especially on the distribution side, to be more network, to support more microgrids, to have more mini grids that are be able to isolate it when it's necessary to enable resiliency goals, to be able to then understand and in all the distributed energy resources that are connected to your distribution grid, and have the visualizations, have the visibility, if you will, to understand where they are and how you can control them. So you need to think about more orchestration capabilities, and can your ADMS systems, can your DERM systems be able to then address those, and when is your utility customers are coming online faster with all these connection requirements, and then is your data and systems ready for those? All of that really has to be built into your investment planning, and a lot of these investment plans are minimally a 5-year plan, if not more. So be able to build a grid mod roadmap and then be able to build a value proposition across these programs are really critical, important to really demonstrate that not only you understand the value you're delivering to your customers today, because you still have to keep the lights on, you're leading towards that future of your clean energy goals, and that's really the objective that we're all trying to achieve. Jay?
All right, thanks, Joe. So I'm going to focus a little bit on the physical transformation of the grid and the digital transformation of the grid, because they are one. Gone are the days when we replace a device in the field that can be automated and we don't automate it. That's essentially be like going out to buy a cell phone and coming back with an old dial-up. They're rarely available, one, and two, it just doesn't make sense to do. So as you upgrade the infrastructure of the transmission and distribution grid, you are performing, almost whether you want to or not, that digital transformation, which is very important and which is needed. But you got to think about how all those systems work together too. So you can have physical assets in the field that perform their jobs. You will have controllers on many of those assets now that gather intelligence and allow those devices to either operate independently to adjust to field conditions, sometimes at the edge, or have a centralized control like a SCADA system. And then you have to have the telecom system, and there are many different backhaul methodologies in use, but you got to pick the one that works for you, and all of those things need to work together because that system is really the important thing. The physical assets working together, the telecom system working together, and your back office systems working together. That's what the grid of the future is like. And I'll give you an example of that. So imagine if you are going to, you have a substation that's one of your critical substations, and you're going to have a camera monitoring that substation. If you have a camera out there, but you have no telecommunications to the camera, are you going to get the value from it? You are not. And if you don't have a back office system that allows either a person or some form of AI to review what's coming in and take appropriate action in time, then the system is simply not delivering the benefit that it's able to deliver. So the physical, the telecom, the digital, all of that has to work together to truly deliver the value that we're talking about here with grid modernization plans. I can give much more examples, but just being conscious of time, I think it's probably better if we go to the next slide. All right, now this slide, benefit cost analysis framework, very, very important for us at Duke Energy. We've talked about this a lot of times, but I want to highlight how important it is. We operate in 6 different states. We operate in Florida, South Carolina, North Carolina, Kentucky, Ohio, and Indiana. We have electric utilities there. Each one of those states values things a little differently, and that's okay. In fact, that is expected. So we have to be able to tailor our programs to what's important to each one of those states. Sometimes the legislature will make laws that apply to us about the types of investments we need to do. Sometimes the commissions will enact rules that tell us the types of rules that we need to follow, the types of investments that we need to make. And they vary. They vary greatly. I'll give you an example. We have one jurisdiction that highly values, a jurisdiction to us as a state, that highly values defense against major storms. Limit the damage from major storms because that costs the customers a lot of money, and limit the time customers are out due to major storm events. That particular jurisdiction, when we're building our grid modernization plans, we take that into account and make sure we value that appropriately for what's important to the regulators and the legislators in those states. We have other jurisdictions, other states that highly value decarbonization. We have some that highly value we'll call it blue sky reliability metrics, your typical SAIDI, SAIFI, CAIDI, those type of metrics. So we have to have the flexibility to build plans in each jurisdiction that addresses specific needs of our regulators. That's very important to do. And then finally, another important thing in this benefit cost framework methodology, you have to be able to take into account stakeholder feedback. When you're working with your regulators, when you're filing rate cases or grid modernization plans, stakeholders are a part of that, and they should be. And when you work with your stakeholders in these states, they have an opinion, and that opinion needs to be listened to and understood. So you have to be able to take their opinions in and be able to alter or add or adjust some of your thinking to bring their perspectives into play. So any type of plan needs to have that amount of flexibility built into it where you can value the importance of stakeholder engagement. And then lastly, I know I said lastly before, but I forgot this part. In a company like ours, we have many different jurisdictions, but we do have one amount of capital that is finite at the company across all of the different states that we serve. So it's also important that we can value each jurisdiction and make sure they're getting the capital that they need to operate appropriately. Again, very important to have a capital planning tool that's flexible. I'll turn it over to Joe.
Great, thanks, Jay. So what I'd like to really point out on this particular slide is some of the finer details that may not be obvious. And number one is traditionally when utilities build these investment programs and trying to justify benefit cost analysis, it's really just sort of a two-dimension, right? It's investment programs and you have a time horizon. You're essentially trying to develop what's traditionally called the benefit cost ratio. You get the cost, you get the benefit, you lay out to the timelines, and you develop the ratio, and hopefully, the ratio is positive and above 1, and then you sort of roll with it. Now, and with this particular process, what we really have introduced, which I'll go into the detail in the next slide, but conceptually introduce the third dimension relative to what we call the grid asset grouping, which means is that we wanted to really dice these investments programs relative to what are the impacts of, is it a transmission, is it the transmission line, substation, or distribution circuits. By doing that, what it allows us to do then is looking at these benefits in a number of these categories, and you'll see on the right-hand side, and you have different sort of color groupings. And traditionally, you value these on a reliability, resiliency, energy cost reductions from a generation perspective, operational efficiencies. We've also really attempted and accomplished sort of a normalization of risk reductions in a number of other areas that put them into the same category from a monetize the value perspective, which that allow us to do is go through the process, collect the data, and then start to drive what's called investment optimization. So instead of a pure benefit cost ratio ranking relative to using spreadsheets, what this process allows you to do is collect the data once, be able to have a consistent process, a consistent way of value these benefits, and then be able to essentially optimize. So how do we do it? So let's take a look at it maybe in a greater level of detail. Next slide. To make this happen, this is really a key really slide to illustrate and how we are able to accomplish that. And if you look at this particular slide, you'll see that horizontally you have the programs, and vertically you have the asset grouping. What you really have to do is looking at how each of the program are having an impact at a asset grouping level, meaning that does this particular investment applies to a substation or a circuit? You know, which circuit are you looking at to essentially putting in what Jay calls self-optimizing grid, for example, right? Which circuit are really candidate for, you know, undergrounding, for example, from a storm protection perspective? All that allows you to do is develop the granular level of benefit and cost and unitize them, and then you'd be able to then optimize, not only across different circuits. So you know which circuits are bubble up to the top. You can then compare that to a grouping to substations, because, you know, a number of circuits are feeding from a substation. And then you can really look across all the different asset groupings. And that, to me, is really the key part of this whole overall approach. Now, people will look at this and say, well, think about, right, the level of effort. You know, if you have a utility like Duke, you got, you know, across, you know, a number of jurisdictions, you got thousands and thousands of circuits, right? Thousands of substations collectively, the number of data points you have to collect. But it's an effort that's incremental. It's an effort you do it once, you get much more accurate data. And then the benefit of having that data available for future planning purposes is tremendous. And that's really what we're looking at. Jay?
Yeah, thanks, Joe. And this is my favorite view, my favorite way to look at how we're doing our planning. And along the top, and this is real world stuff for us at Duke. This is how we're building our plans. This is representative, but it's real world for us. So along the top, you have traditional programs, hardening resiliency programs, grid modernization programs, asset reliability programs, et cetera. And those programs run across your whole system. And one of those programs might be an automation program where you're going to replace a certain type of hydraulic reclosure with an electronic reclosure. Or it could be your pole replacement program. It could be relay upgrades and relay upgrades from electromechanical to electronic. And all of that's great and very important. But a better way to look at it, and the way that we're looking at it, is by these three asset groupings that Joe mentioned: transmission lines, substations, and distribution circuits. And what we're doing is we're taking a look at each one of those major asset classes and looking at all the different programs that could be applied to each one of those asset classes. Programs that make sense to do to bring each one of those asset classes up to a certain operating standard. So to bring circuit X651 up to our operating standard, we need to do these 5 diamonds that you see on this slide. That right there has built our investment plan for that circuit. Do the same thing for substations, same thing for transmission lines. Now, conveniently, that's how we're going to build it too. We're not going to build it by program. We're going to build it by substations, transmission lines, and distribution circuits. So we're not going to visit the same substation 5 or 6 times. Imagine if you were going to do work in a substation and you said, okay, we're going to change the relays out in January. We'll come back, we'll work on the breakers in November, and then we'll work on high side switches the year after that. No. How about one engineering package, bring the crane there one time, one outage for our customers, maybe bring the mobile there one time, do it all at the same time in one fell swoop. That's much more efficient. So we're valuing these programs via those major asset classes because it's the best way to do it. It matches how we're going to do the work in the field, and it really gives us a great story to tell to our regulators. Because it's pretty straightforward. Well, why did you pick the projects that you decided to pick? Well, we've been able to grade based on costs and benefits each one of these three major asset classes. And this is why we're going to go work on these substations, these circuits, and these transmission lines in this 5-year window, or this 3-year window, or this 4-year window. So it's a really practical way to value things. And our capital planning tool allows us to do this. It allows us to value by these major asset classes, which turned out to be very, very important for us. So I could talk about this slide all day, but I'm not going to, fortunately, for all of you. We can go to the next slide. Okay, Joe, I think I'm going first on this one, right?
Yes.
All right, we'll take that as a yes. I had misplaced my notes, but so Copperleaf Value Framework, essentially what this means is there are different ways, different characteristics of value for each one of these investments. And that's important because I really just want to make one point here. You have to have a goal. When you go in to create a program for grid modernization or improving the grid, anything like that, you can't go in and say, my goal is to go modernize the grid, or my goal is to invest capital or something like that, because that's not the goal. The goal is actually something of value that's going to be delivered to customers. And you need to make that the goal and state it. So for example, one goal might be, we're going to have, we're going to select the 3 asset classes, and we're going to work on those over the next 5 years. We're going to select those particular assets that reduce SAIDI the most for the least cost. That's a pretty good goal, and it makes sense for our customers. That's one example of how you can do this. So as you're building your plan, you got to have some goals. That was a very simple one, but one that a lot of utility folks understand, one that a lot of customers understand too, because it has to do with their reliability. That's part of the value of being able to adjust the way that different things are measured and valued in the tool. And I'll turn it over to Joe.
Thanks, Jay. I'll wrap up by basically indicating that if you look at this investment planning and think about how you want to optimize and some of the goals, I remember when we started this project, Jay essentially gave us a challenge and said, well, we wanted to optimize indicating customer impacted and then customer minute impacted, interrupted. And imagine if you have to use spreadsheets to do that. And then there's really not a way to do it until you use an optimization engine such as Copperleaf, right? Not only this provides you with the ability to quantify, the reliability risk improvements, but also normalize other risk improvements in the value unit that are consistent across each of these, and then you can play a lot of different what-if games. So the ability we can, take some optimizations and talk through with the business, and then come back and next day and say, what about these scenarios? How do we have a budget constraint across transmission and substations distribution? How does that value look differently? Can we focus on C&I customers to look at, their customer minute interrupted and so on and so forth? So the ability to really do true optimization is really where we got to the next level. And it's been certainly a very interesting journey between Duke Energy, Black & Veatch, and Copperleaf, and we're not done yet, and we will continue to refine it. And we have a lot more to come. We needed to, work with the industry to understand how do you, for example, quantify carbon reduction benefits? How do you quantify additional resiliency benefits? How do you develop a probabilistic model for rare events such as the winter storms we had in Texas, right? All of that can then drive the optimization that this particular platform is able to provide to you. So I'm going to now turn over to Rachel and talk about some of the working group ideas that we have, and hopefully folks on the phone might be interested in joining us in that journey towards continued refinement and improvement.
Yeah, absolutely. Thanks, Joe. Yeah, so I mean, this is a topic that we've seen a lot of interest in, at Copperleaf. And Joe, of course, with Black & Veatch, you've been hearing a lot of interest about best practices around these issues. So we at Copperleaf, we've actually teamed up with Black & Veatch to put together an industry working group around investment planning. And we're currently seeking around 5 to 10 founding members. So please, if you're interested, reach out. And we'll also follow up to all of the webinar attendees with an email with these details, but we'd love to have you in the working group. So at this point, we have about 15 minutes left. We're going to turn it over to a Q&A. Joe, Jay, thank you so much. That was such a great overview of these trends and the challenges we're facing around investment planning in the context of grid modernization. I'm going to hand off, and we'll just send some ask you guys some questions that have come up. And we actually have a long list of questions, which is good. So, but hopefully we'll have time to get through several of them. The first one that I'm seeing here, and this is related to the content on those last slides, is maybe I'll send this to you, Joe. What do you see as the main challenges to this asset investment planning framework, the main challenges, and what needs to happen to overcome those challenges?
I think the challenge is really more from a utility perspective is sort of, what do we need to do minimally versus how much we can really articulate the values across different business units through really trying to tackle these clean energy goals and carbon reduction goals. And how do we really look at these investments more holistically and in the long horizons? And because if you look across these different challenges, especially when you're trying to justify additional investments to address, low probabilistic events that may happen or may not happen, and you're gonna potentially ask for more money, right, from your ratepayers and your customers, and that is a daunting task. So, that's why I think we're forming this working group across the industries, because we wanted to, understand the lessons learned. We wanted to hear your stories and then be able to come up with, really a set of best practices from an industry perspective.
Great, thank you. Jay, are you still on the line, or did you have an internet issue again?
I just dialed back. I just dialed in via my phone.
Ah, perfect timing. I'm not sure how much you heard of Joe's answer, but I was wondering if you could comment on what you see as the main challenges to this new asset investment planning framework and how to overcome those.
Can you repeat the question? I missed the first part. Sorry about that.
Oh, sure, absolutely. The question was, what do you see as the main challenges to adopting this new asset investment planning framework, and how to best overcome those?
Yeah, there's a lot. So the first one is you kind of have to break free of what you've been doing for many years. I mean, for my entire career anyway, in transmission distribution, we did asset planning one way, and we did capacity planning another, and those two really didn't very often connect with each other. So we've had to break that paradigm and bring those together. That is certainly one big challenge. Another challenge is you got to have data to do it right, to bring the transmission and the distribution and generation together into one real plan. You got to be able to take a look at what each of those plans are each year and work it together. Again, not something that we've always done. And then sometimes you have to actually be able to explain it effectively to your stakeholders and effectively to your regulators, because it's different for them too. They've not always seen planning this way. They have different ideas about how it might want to work. Sometimes they may want you to go faster in one direction than you're ready for. So there's a lot of challenges. We've been working at it for a couple of years, really, and are just starting to get our arms around it.
Hey, Rachel, I want to comment on Jay's comment about the data, and then I saw some questions about the whole approach sound a little bit complex. What I would say is that, it's really thinking about what you have versus what you're going to get. And yes, there is going to be a little bit more upfront investment into data, understanding, getting your stakeholders together, right, to understand how do you quantify and qualify these different value streams. But the key is that, and then you invest in once, you put them into a platform, and then you get to really enforce that governance going forward. And so if we look at in the long run, you're actually going to save a lot of time and then really improve your quality, efficiency of your planning going forward. Because if you don't, what's going to happen is that you get people managing all these different spreadsheets, and these spreadsheets may not have consistent understandings or consistent formulas even built in. And that's going to present a lot of challenge. So the savings are going to be tremendous if you get on this journey.
Great, absolutely. So maybe a follow-up on this same topic for Jay. How long did it take to get this planning solution going at Duke?
Well, we really started the transition from traditional planning to the more comprehensive planning, I'm going to say about 5 or 6 years ago. And, it began when we realized that we needed to start modernizing the grid because of our customers' expectations of us, and because of the way that some of the issues that we were experiencing by not being ready. That's probably the best way to put it. By not being ready for growth in distributed energy resources. We need to be ready, understand what it takes. And, so this has been going on for 5 or 6 years. I can tell you it's taken on, and it gained a lot of momentum when we began to file our grid modernization plans and our grid improvement plans with our regulators. That's when really we started to understand you've got to do a better job at putting together a comprehensive plan with benefits, with costs, and those compared to show that you did the best job. I would say that experience was about 4 years ago. We didn't have a great experience in one of our jurisdictions. We learned from that and have done a much better job since then. And now, for about a year, maybe a little bit more than a year, we've been working on let's transition from programmatic approach to major asset group approach. For example, distribution circuits or circuits served from a common substation. Let's build the plans based on that. So it's been very much an evolution, and we've learned along the way. But it was certain, it's been a good 5 years we've been on the journey.
Great. Thank you, Jay. I have another question here. This one I'll direct to Joe. How do you incorporate asset health or condition into Copperleaf? Have you integrated your planning in reliability systems?
Yeah, no, great question. So basically, the asset health data are actually a very important aspect of driving the overall planning. If you look at these investment programs, you essentially have a group of programs that are essentially asset improvement reliability. So in order for us to do that, we needed to collect the asset condition data, and we need to derive specific asset degradation curves and understand the probability of the failure and consequences of the failure. And then we were able to work with Copperleaf to build that into the system, and then be able to then drive the essentially reliability risk reduction values, and then be able to incorporate that, and then compare that the same way as if, let's say we have a investment in grid mod and ADMS systems or IBVC programs, and they would have a similar set of values. And then we essentially compare them in the same way and then drive optimizations. And that's really the key is, having the entire framework and be able to look at the asset-specific improvements as well as system-specific improvements and be able to optimize across the board. And then really looking at, as Jay said, right, looking at circuit by circuit, substation by substation, because the work is organized that way, the execution is organized that way, and then we can really then pinpoint, go back to the CI and CMI impacts, because you can look at circuit by circuit which customers are connected to those, and then you can specifically pinpoint benefits of those. And then that's really to me that this is innovation in industry, and we're going to continue to improve on that.
Wonderful. Thanks for sharing that, Joe. Jay, I have a question for you now. How do you take into account availability of various resources or assets to obtain the reliability targets?
So make sure I got that right. Availability of various resources?
Yeah, the question was, how do you take into account availability of various resources or assets to obtain the reliability targets?
Okay, you can look at a couple of ways. It may be availability of intermittent resources, such as solar. Maybe that's one way to look at it. Wind would be another intermittent resources. Another thing that we have to take into consideration is we have to go hire people to do this work in the field. That's another resource that we need. And that one's difficult. We've struggled with that, obviously. We've been in a pandemic for a year, and it's been hard to build our workforce up to go and implement some of these plans. But we're figuring out a way to get over that now. So that's what's really got us right now is that resource availability puzzle in the middle of the pandemic. But we have ways around it. We have ways of growing it, and we're in implementation with a lot of these plans. If it's about intermittency, and I probably should ask a clarifying question there, but I can't see the chat because I'm kicked out. But if it's about intermittency of resources, there are lots of different ways to deal with that. It's not a perfect science right now. If we're going to use a variable or intermittent resource as a reliability tool, we tend to make sure it is part of a microgrid. In many cases, we'll use batteries, and we are in a significant growth period for battery installations right now. Hope that made sense to whoever asked the question.
Yeah, well, I think you gave a few different answers to a few different ways, so hopefully it scratched the itch.
Sure.
Jay, while I have you, and before we lose you to another internet issue, just kidding, but how do we quantify the benefits of carbon reduction, or more generally the impact of climate change in the plan?
Yeah, that's a great question, and I would ask our stakeholders that same exact question. Because, as we're building these plans, it's got to take into consideration stakeholder engagement. And this would be, the partners that we work with that represent environmental interests, the partners that we work with that represent large commercial industrial customers, the Public Service Commission staffs and so forth, and then, the Office of Public Counsels and all those that represent the ratepayers. Valuing carbon is important, and it's not something that we want to do alone at Duke Energy. We need to get insight from those stakeholders and come to a consensus on how to value it. That's really the most important thing that we've learned around something like that, is you can certainly put a value in. It's going to be too low for some groups and too high for others. Much better to try and gain some consensus among your different stakeholder groups and use that in your cost-benefit analyses.
Yeah, Rachel, to add that, part of the analysis that we went through is really just focus on what we call the DER enablement, all right? Ability to have a physical and digital grid capabilities to enable DERs, but that's really more of a capability. side, and a key really objective of our working group is really work with a number of industry peers and really understand different requirements and different objectives, and come to some consensus on what we value carbon reduction goals and investments, because we believe a number of these every state, right, will come up with those requirements, and if we have an industry consensus, it'll be more it'll be easier for us to get through the process and get on the journey with that transformation.
Great. Well, guys, thank you both so much for joining us today. I see we're at the top of the hour, so we're going to let everyone scurry off to their lunches or meetings, or in my case, dog walking. But thank you so much, and I hope to hear from the audience about joining the industry working group. So we'll send out that email. Thank you so much.
Wonderful. Thank
you. Thanks for joining us.